Sorting provides an organizational clarity to our applications and can also reduce the complexity of a problem. There are a lot of different sorting algorithms, where an algorithm is a series of steps to accomplish something. So how do we sort a list of items? In this case, I've got a list of numbers in an array. How can I sort those? And there are various algorithms to do that. So we have a tree sort algorithm, a shell sort, a merge sort, a comb sort, and a whole bunch of others. But perhaps the simplest one to understand and to demonstrate is the bubble sort. The bubble sort uses a system of comparisons and exchanging or swapping items. It's not the most efficient algorithm, but again, I think it's one of the easier ones to understand. So let's look at how a bubble sort algorithm works. I have an array called myArray, which holds 7 values. These are not in any particular order, so we want to order them. We want to sort them, and we're going to sort them in an ascending method. The bubble sort works just as well for a descending method. All we would do is change the less than symbol that we see about halfway through to a greater than symbol. I'm going to dim 3 variables, I, j, and temp, all as integers. We're going to use I and j as our counters going through 2 nested loops, and temp as a variable to temporarily hold a value while we do the swap. It's a very simple algorithm. We have 2 nested loops. The first one for I is my counter, equals 0, my very first index of the array, to myArray.count minus 2. Now remember, we start counting with 1, so myArray.count is 7. There are 7 values being contained in my array. So myArray.count of 7 minus 2 is 5. That's going to be our second to last element because we're working with indices here. So we're going from I from index 0 to index 5, and that's the value of 12. Inside that then is a nested loop of for j is my counter equals I plus 1. I'm going to go whatever is I and go to the next element after that. So as I is 0, j will start with 1. If I is 1, j will start with 2. If I is 2, j will start with 3, and so forth. And the j loop goes all the way to the last element of myArray.count minus 1. In this case, that'd be the 45, or element 6. 7 minus 1 is 6. Now within those nested loops, my executable code is I want to compare the element at myArray sub j to the item at myArray sub I. And if the element at j is less than the element at I, we're going to take the element of I and temporarily place it into a variable called temp. Then I'm going to replace that element I with the element j and then put temp into element j, in essence executing a swap. So our first time through the loop here, I is 0 and j is 1. And here we're comparing element j of 15. Is it less than element 0 of 23? It is. So we're going to swap those two. So now 15 is element 0 and 23 is element 1, and j becomes 2. Now we're going to compare 15 to 82. Well, 82 is not less than 15, so nothing happens. J becomes 3. And now we're comparing 4 to 15. Well, 4 is less than 15, so we're going to swap those two. And now we have 4 in element 0 and 15 in element 3. Now we're comparing 4 to 39. Nothing happens because 39 is not less than 4. Same thing with the next j of being 5. 12 is not less than 4. We go the next j of j being 6, and 45 is not less than 4. We've now completed our j loop. We've gone all the way to that very last element. And at this point, after our first pass through I, we should have the lowest value in element 0, and that's what we have. Next I is I becomes 1. We're going to now restart our j loop, starting with the element after I, in this case is 2, and we're going to compare element 1 and element 2. Well, 82 is not larger than 23, so nothing happens. Next, j is 3, and now we're going to compare 15 to 23, and 15 is less than 23, so we're going to swap those two values. The next j then is 4, and we're going to compare 15 to 39. Again, nothing happens there. Next j is 5. Comparing 12 to 15, we're going to swap those two. So 12 is now in element 1, and we're comparing it to the next j, which is 6, and nothing happens. We've now gone through 2 iterations of I, and the 2 lowest values are in elements 0 and 1. I then increments to 2, and we're going to compare element 2 to element 3, which is our first j in this case. 23 is less than 82. We'll swap those two, and then j becomes 4. And we're comparing 23 to 39. It's going to skip that. Element 5 for j, we're comparing 15 to 23, and since 15 is less, we're going to swap those 2 items. And then j becomes 6, and we're comparing 15 to 45. And again, we're going to pass on that one. The next I becomes 3. We're comparing 82 to 39. 39 is less, so we're going to swap. Comparing 23 to 39, again, we're going to swap. And now comparing 23 to 45, nothing happens there. 4 iterations through, we now have our 4 lowest values in the first 4 items of our array. I becomes 4, comparing 82 to 39. Obviously, we'll swap those 2. And then comparing item 4, 39 to item 6, which is our new j, 45 is not less than 39, so nothing happens. We now get to our last I iteration where I is 5. And we're going to compare I to the j, and j is only going to be once, which is I plus 1. That'll be the same as our last counter. So we're comparing 5 and 6, and obviously we're going to swap those 2 in this case. And now we have our 4 loops completed, and all 7 elements are in numerical ascending order. Now, the nice thing is with arrays, there is a simple sort method already built for us. All we need to do is call Array.Sort, and in parentheses put the name of our array, in this case my array. And it would do the exact same thing we just did with the bubble sort. So why did I go through the bubble sort? Well, the problem is, what if I wanted these in descending order? I would use the bubble sort for that, and then instead of a less than between element j and element I would use a greater than. And that would sort my array in descending order with the largest value at the top and the smallest value at the bottom. We'll see down the road there's an alternative to using these sorting algorithms that's really pretty slick, and that's language integrated query, or what we call LINQ. LINQ is used for filtering a data collection, but also allows us to sort the results of that filter in ascending or descending order. I said sorting can reduce the complexity of a problem. Let's see an example of that in our previous problem of the exam scores. To demonstrate how we can simplify a project by sorting an array, I've returned to my exam score stats problem. I'm going to go back into the code. Now, we ended the previous video by using a for each loop and iterating through each element of our score array, finding the sum of all those elements, and then using 2 ternaries to find the high and the low. I'm going to refactor this by using that Array.Sort method, pass it score. That'll put everything in ascending numerical order. And then I've got dim sum as integer. Well, an array actually has a method called sum that works with numerical arrays. That will get me the sum of my score array. Now I want to find the high. I'm going to change dim high as integer, no longer equal to 0, but now it's going to equal score, and I want the very last element, so that's going to be score.count, or I use .length, minus 1. That'll get me the last element. And then my low score is going to be the very first element, so it'll be score element 0. I no longer need this for next loop. I've reduced my code significantly, but let's make sure this still works. I'm going to run my application, and I'll click the Show Exam Stats, and I'm getting the same results. 83.3 is my average, 98 is the high score, 62 is the low score. So that's how we can use sorting an array to find the extremes of the low and the high, and I also introduced using the sum method. Now, it often pays to look at the IntelliSense or look at the documentation at Microsoft.Learn, because there's other methods besides sum. If I just say score dot and look at the IntelliSense and scroll down through here, notice that there's one called average. Well, I can use that. I'm going to get rid of this dim sum as score. I don't need that because here I can change this to score dot average dot toString with 1 decimal place. I reduced my code by another line. I'm not having to declare a variable out in memory. That's just a very small savings, but let's make sure this works. And I get the exact same results of 83.3 for my average score. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.